Assalamu alaikum, dear students. I am Mr. Kadeem Khan and I am a lecturer in the Institute of Computing, Quad University of Science and Technology. Today we will take lecture number 10 of the Object-Oriented Analysis and Design subjects, in which we will discuss the Rational Unified Process Model. This is the discussion agenda. It contains the topics of the RUP model, diagrammatical representation of the RUP model, phases of the RUP model, application of RUP model, advantages and disadvantages of the RUP model. The Rational Unified Process Model. Rational Unified Process Model is in fact software development life cycle model. It is defined by Rational Corporation of the IBM. This is in early contributors to the development and refinement of the unified process model and the builders of the complete environments, which includes the tools and technology that support the process. Basically, this model is very much technical as compared to the previous models such as waterfall model, incremental model, prototyping model, and spiral models. The rational unified process model is in fact an example of a process model which takes UML as a unified software development process. Basically, UML is a language which is basically a graphical language which defines the structure of the software and also used for the designing purpose. So basically, unified process model is a model which in fact takes UML artifacts as the designs of for the software designing. It is a good example of the hybrid process model because it brings together elements of all generic process models such as support, iteration, and states, good practices in specification and design, and rational unified process model also provides the technical overview of the designing as well. The rational unified process model recognizes the eventual process model represents as a single view of the processes. So all the different phases of the process are in fact here are provided as a single view in the rational unified process model. Okay, the phases of the rational unified process model. There are 5 phases in the rational unified process model. The first one is called inception phase. The purpose of inception phase is to establish the business goal of the system. Basically, it defines what the system will achieve the business to the particular clients. All the external entities, which including the people and other systems such as the hardware and software systems, should be defined and that will interact with each other in the and define these interactions. So then using this information to assess the contribution that the system makes to the business. So rational unified process model in fact identifies such entities which includes all the clients, all the stakeholders, and also all the internal and external systems, for example hardware and software systems. So they uses all these entities to define the business goals and what is the in fact business requirements, what sort of problem we are going to solve, how much benefit we can get through this particular product. This is defined in the inception phase. All this, if this contribution is minor, then the project may be cancelled after this phase. For example, if the system benefits are the objectives are minor, then we will cancel the rational unified process model and we will not develop the software. Second phase is called elaboration. As its name indicates, elaboration means to make particular things very much clear and in fact further to explain the particular uh, thing. The goal of the elaboration phase is to develop an understanding of the problem domain and to establish an architectural framework for the system and to develop the project plan and to identify the key project risks. Basically, in this phase, we define the understanding of the problem. Understanding of the problem means that we will develop such an architecture which will provide insight into the problem. And also it develops the plan for the development. Uh, Plan for the development means the schedule, cost, and the budget and other resources required to develop the project, and also to identify the project risk. Basically, risk means that the key factors which can affect quality, cost, and schedule of the project. So risk can in fact damage the project. Also, it can delay the project as well. So risk must be identified and resolved prior to the development of the project. On completion of this phase, you have a requirement model for the system called the UML use cases, an architecture description and development plan of the software. Basically, when this phase is completed, you have a complete overview of the UML and also architecture styles, and also we have certain frameworks for the software development. Also, we have the plan for the development of the software. The plan here means all the phases which we will complete and the resources required to complete these phases and the time required to complete these phases. So this will be the plan of the project. So in this subject also we have a focus on the UML. So that's why rational unified process model is very much important. The construction phase, which is the number third phase of the RUP process model. In the construction phase, as its name indicates, in this phase we construct the software in practical manners. So basically in the construction phase, the software is developed using certain computer programming and computer technology. For example, C++, C Sharp, Java, and other, for example, web development technology like ASP.NET, yeah, PHP, etc. So we uses different sort of computer tool to develop or construct the software here. So part of the system are developed in parallel and integrated during this phase. So rational unified process model develop all the units or the modules of the products in parallel and then they integrate with each other either top down or bottom up approach. On a completion of this phase, we have a framework or a software system and associated documentation that is ready to be delivered to the particular users. So when this phase is complete, we have a practical product which can be used by the user. Last one is the transition phase. In the transition phase, as its name indicates, the transition means to transmit a product to another environment. So here it means that when a product is developed in the construction phase, and then we have to transition phase, and in the transition phase, we in fact using that products we install the product on the customer environment, and the product continue to provide the services to the user. Basically, in the transition phase, the user community and that people who working on the product and in the real environment, the product is installed for the particular user. This is the something that is ignored in most software process model, but in effect inexpensive and sometimes problematic activities. So in the most of the software process model have no transition phase. That means the installation phase, because they in fact think that this is obvious that we have to provide it to the customers, but this is very much important because software should be working on each and every environment of the users. For example, if they are using different operating system and hardware and software, so the system must work on every environment. On a completion of this phase, we have a documented software system that is working correctly in an operational environment. So after completing this phase, we take a sign from the customers, and this will act as an agreement that the particular product is completed and provided to the particular customer. Last, we have the production phase. The production phase in other models is also called the maintenance phase. So this phase occurs when after the deployment, if there is certain sort of the maintenance and evolution required in the product. For example, in this phase, the uh, project manager or the production organization, in fact, monitor the software that whether it creates certain problems or not while using the software by the user. So maybe there may be certain defects or and errors or certain sort of the problems arises in the using the product. So then in the production phase, we maintain or evaluate the product. This is the diagrammatical representation of the rational unified process model. First one is called here the inception phase, then we have the elaboration, then we have the construction and transition, and the last one is the production phase. In the inception phase, we communicate with the user and also create the planning. In the elaboration phase, using this planning, we model the softwares. In the construction phase, we using these models, we develop the softwares practically. And in the transition phase, using that construction, we deploy the software at the user environment. And at the final, we in fact produce the product, and that is called production. And if there is a certain problem, we develop another increments, and the software is in fact here produced as an increment. And it is also called release phase, that the software is practically launched in the market. Rational default process models, in fact, every four of these, the first four are very much important, and last one says that it is maintained. So in inception, elaboration, construction, and transition phase, everyone, in fact, passes from the business modeling, requirement analysis and design, implementation, testing, and deployment. So, for example, in the inception phase, we perform business modeling, then we have certain requirements, but we have less designing, we have certain sort of less designing, and we have less implementation because most of the requirements are incomplete. We also have less testing, and we also have very much less deployment. So this less deployment and less implementation and less testing is because maybe that the requirements may be not complete with us. Also, there is no modeling and designing with us, so that's why these four different other phases are incomplete here. In the elaboration phase, we in fact model the software using UML. So then we have requirements again, and again we have analysis and design, but this time we have some full designing, and then we have implementations, and then we have testing. But initially we have some fewer tests, and when the time progress, we have more tests here. And deployment, we have less deployment, but when the time progress, we have more testing here, deployment here. Then we have the construction phase. Construction phase, we practically develop the softwares. So we have more business modeling, more requirements and analysis, and we have maximum construction here. So this is the construction phase. We have maximum construction and maximum testing as well. Sometimes we do more testing, then we do less testing, then again the testing graph becomes higher, and then again we have less testing, and then we have also higher testing. And deployment is also on the peak here. So during the construction phase, we also develop the software and releases the software. And finally, we have the transition phase, which actually means that to install the software on the user environment. So we have less business modeling here, very few requirements, because possibly we have some new requirements, and then we implement and test the software. We have also less analysis and designing, because already we have done a lot of designing here. So here we have less designing, and then we have the implementation phase, which is also very not much complicated, and not completely implementation here, because this is just a transition. Possibly if there is certain changes, we perform here about few implementation. We have also few testings here. Also we have less amount of the deployment. So when time progresses, the rational defined process model is also complete. Now, six fundamental practices of RUP model. So it means where will you use RUP model? First of all, develop software iteratively. If you want to develop the software iteratively into multiple increments, you can use the RUP model. RUP model, in fact, tackle high risk elements on the every stage of the project and increases the understanding of the problem and make necessary changes until you reach the solution of the problem. Manage requirements. It in fact describes how to organize and keep track of functionality requirement, document trade-off decision, and business needs. Basically, RUP models has higher management for the requirements. It manages the requirements in a good fashion, because constantly we takes the different sort of feedback from the customers. So hence, we have a good management of the requirement. Use component-based architecture. Because RUP model defined component-based architecture, which means that all the units are developed isolatedly, and then they are integrated with each other. So we defined here component-based architecture. In fact, architecture specifies the blueprint or the abstract view of the system using certain UML techniques. Visually model the softwares. RUP model provides us the model of the software. Basically, all the components of the software are provided in the visual environment, so that's why it gives us a good overview of the all components and the modules of the product. Refine software quality. RUP model provides us good quality results. It enables you to evaluate and control the quality of all activities during the software development. So basically, a RUP model has a good quality because each and every phase passes from the every phases of the requirement, the software development life cycle model. So that's why it has focuses on the more higher quality. Control changes to the software. It gives you the ability to control, track, and monitoring changes with enables constant and successful development of the software. It helps you to create a secure workspace by isolating it from the changes, which in turn brings your team together, making them work as a unit. So RUP model in fact help us more control over changes in the software. So basically, when you take iterations, you iteratively develop the software as we saw in the diagrammatical representation of the RUP model. So by this way, we have more control over the changes in the software. Building blocks of the RUP model. So, how different elements or units are identified in the RUP model? How we can define different sort of entities in the RUP model? This is defined by four different methods here in the RUP model. Number one, workers. Workers are the people who will work, including, in fact, that is the behavior and responsibility of the individual or group of individual together as a team working on the activity in order to produce the artifacts. So when we have works here, so who will produce different sort of the artifacts, different sort of the components, and different sort of the documentation using the RUP model. So by who means here the people who are responsible to work on the RUP model. Activities. Activities means different sort of phases. So it is defined by the how. The unit of work that a work is performed, activities should have a clear purpose, typically by creating or updating artifacts. So basically by the activities we means that how many phases, how many tasks and how they can be performed. Artifacts, the what? Artifacts means the components or the modules which defined by the what. The artifacts represents any tangible output that emerges from the processes, anything from new code functions to document to additional lifecycle models. Basically here what means that how what sort of the artifacts we are going to develop or what sort of the code, what is the code and what sort of programming will be required to complete the product. Workflow, the when in fact define the schedule or schedule of the project. So it represents diagrammed sequence of activities in order to produce observable values and artifacts. So also it defines that the sequence in which particular activities will be called while to produce the particular artifacts. Now, advantages of the RUP model. RUP model, in fact, puts emphasis on addressing very high risk areas. Basically, RUP models, like the spiral model, it focuses on the risk resolutions. So, risks, in fact, which are the factor which can affect or damage the projects, and these may affect the quality, cost, or schedule of the projects, and they must be taken very seriously. So that's why RUP model emphasizes on the risk analysis here. So it doesn't assume a fixed set of the firm requirements at the inception of the project, but allows to refine requirements as project evolves. So initially the requirements are not fixed here. So requirement may be changed. And when the refinement is occurring in the model or in the project, so then we have also new set of the requirements and evolutions continues in by the refinements of the requirements. It does not put either a strong focus on documents or synonyms. In RUP model, we have no strong documentation. We just focus on the initial and informal documentation because it's very huge model, and also it has a lot of phases. So that's why just wasting time on the documentation is not a wise thing. The main focus remains the software product itself and its quality. So main focus in the RUP models is the software products, and it doesn't focus on the quality here. Disadvantages of the RUP model. RUP model is in fact particularly an agile process model. The recent studies have shown that by adopting the right essential artifact, RUP is an agile. Agile means that very quick software development. Agile is in fact a word which means that very efficient, and within a few weeks the product is available to the user. So as a first increment. So RUP model basically you as you saw that this also uses the agile techniques because first increments is launched by just executing 5 phases. So that's why this help us to achieve the agile process model. It fails to provide any clear implementation guidelines. Secondly, uh, RUP models is not providing any sort of implementation guidelines. It just provides implementation guidelines about the UML, but in practical languages like Java or C Sharp or C++ or any other tools, it don't support provide that when should we use the particular tools in which cases. So RUP leaves the telling to the user entirely. Basically, RUP is very much dependent on the user. We always involve the user here. So but sometimes non-technical users can misguide us. So that's why our repeat models basically very much depends on the user. So hence, this model has the problem here. Respected students, this is the end of the lectures. If you have any question, you can drop in email at my ID. My ID is m.kadeem@kust.edu.pk. I will wait for your questions, and if you want to read more, you can use these two books references here. So you will get another informations. So, but this slide is also very much important and very much essential. Thank you very much.